All right, fine. The last type of question that comes, it's this one. They will tell you a force F, the electrostatic force F. It is experienced on the charge Q, let's call it Q1, and then Q2, and then I'm going to write divided by the R squared. These are the questions where they say we double the charge, we half the distance. What will be the new charge? So this is how you do it. Number one, take the original formula. Write it like this. Write it as F electrostatic, because it's electrostatic phase, I put the E. And then you are going to spread out. You tathamul the equation. You put your K, you make a nice space. You put Q there, whether it's Q1, it doesn't matter. And another Q there. You're making a nice space. Can you see that? Then when it comes to R squared, don't write it as square. You tathamul it. Okay, you break it down. You spread it out. You write R. Make another space R. We know it's times. We know that. You keep it like that. So this is going to answer your question when they say we double the what you call. You also saw this one when you're doing Newton fourth law, gravitational. They say we double the mass. What will be the new force? A quarter or whatever. So now take that original equation. Write it in one color. Maybe using your ball pen. Red, you can use red, you can use blue or whatever, but I prefer you use black or blue or a pencil. Then the changes that they're going to make, they're going to tell you, you use a different color. If they say, if the force is just F, they'll tell you that the force is F. If we double one of the charges, so you come with a different color, you go to one of the charges, just put a 2, you double it. They keep it like that. That's it. So the change that you made is the yellow 2 on the right-hand side. I get it? So that means on the right-hand side, you only have 2. If you have 2 on the right-hand side, also balance the equation by putting 2 on the other side. That means the force will be twice, will be 2F. If the force was 10, it's now 20. You get it?
Yes.
All right. Now let's go back. Let's do another one. What if they say if we double one of the charge and we triple one of the charge? Now, the numbers that you have, it's 2, 3. But remember, there is multiplication. This is multiplication at the top, isn't it right? So it's 2 times 3. That means the right-hand side has been multiplied by a factor of 6. That means the other side, you go put 6. That means you 6 times the force. The force is 6 times greater. If the force was 10, it's now times 60. Is it making sense? All right. Let's go. Let's do this. This is nice, né? Now, if they say we double both the charges, you've got 2, and then we triple the distance. We triple what?
The distance.
Now what? The distance, there's 2 of them, those one. So that means you put a 3 here. You also put 3 in the other one. Both of them. Then at the top, you're having 2 and 2. Meaning at the top, you're having 2 times 2. At the bottom, the yellow one, it's 3 times what? 3. Am I right, ne?
Yes.
That means at the top, you end up with 4. At the bottom, you've got what? 9. You're not adding, you're times it. 4 9 there. That means the force will now become 4 9 there. Is it making sense?
Yes.
Perfection. Now, let's go back again. Let's mess up with this thing here. What if now they say, now you are going to double the distance, which means it's going to be 2 and another 2. Now remember, those 2 are appearing at the bottom. That is 2 times 2 at the bottom. There is nothing at the top. You know, when a number is at the bottom, there is nothing at the top. There is something at the top. Invisible 1, isn't it?
Yes.
Yeah. So that means you now have 1 over the 4. That means a new force will be a quarter than the previous one. Is it making sense?
Yes.
Perfection. Now, another one, maybe they can do this. Let's say they say, now we have both the charges. We have them there. Am I right?
Yes.
And then we make the distance to be a quarter. We quarter the distance. You're thinking quarter, Skamba. So that means it's 1 over the 4 and 1 over the 4. So at the top, I've got half times by half divided by 1 over 4 times 1 over 4. You can actually put that in your calculator and get the answer one time, but I'm going to do it one step at a time. At the top, we've got 1 over the 4. At the bottom, we've got 1 over the 16. Then I can write 1 over the 4 times the 16 over the 1. And when you multiply by that, you end up with what? 4. That means what we did on the right-hand side, we basically multiplied it by 4. So that means the force will be 4 times greater. Is it making sense?
Yes.
All right, good. So now I just told you we double, we triple, we quadruple. Now, the same type of questions, they're going to ask them in a way of addition. In a way of addition. In the way of addition. In the way of addition. They must say to you, listen, if the original distance was 5 meters, and then on that distance, the distance is increased. It's increased by 15, which means you're having the 5 meter. Now you increase it by 15. It now becomes what? 20 meter. You see, they're using addition. But even though they're using addition, you want to see, Hori, that previous distance was multiplied by how much to get a 20. So in other words, you say 20 divided by 5. Yeah. How much is that? 20 divided by 5. You get a 4, ne? Yeah. So in other words, it's another way of saying we quadruple, we multiply the distance by 4. That's what they're saying. So without telling you we multiplied by 4, can you see? You need to figure out that statement. So that means the distance was what? Times by 4, times by what? By 4. Therefore, at the bottom, you got 4 times the 4. You know at the top is the bottom. So now you're having 1 over 16. So that means the distance becomes 1/16. Can you see that?
Yes.
It is good, ne? All right, so let's repeat another one, like this one. Okay, because I know they love it to do it. They say the person was on the surface of the moon. Now he's now how much distance above the surface of the moon. Now, let's just say now, they say the distance was 5 meter. Then the distance was reduced. Can you see that? Was reduced by 2,5. So that means the distance was 5 meter. It is now reduced by 2,5. Or any other, they can even say 1.5. It doesn't matter. 2,5. And then you end up with 2,5 still. Can you see that? So you want to compare the final and the initial. You always take the final, which means you're going to take 2,5 divided by 5. You're going to get a half, 0,5. Can you see?
Yes.
That is a way of them saying we half the distance without saying we half it. You need to figure out, did they half it, they triple, they did what? So that means we half the distance, we half the distance. So at the bottom, my friend, we got a half, multiplied by half. Remember at the top there's a 1, ne? So that means at the top it's 1, at the bottom it's 1 over the what? The 4, ne? But at the top it's 1. So that means finally you end up with the 4. That means you multiplied by 4. That means the force is 4 times greater. Thank you very much.